Alright, welcome back to Meteorology 101. And this video I'm just going to talk about weather charts. We're going to cover the surface chart and the upper level charts just a little bit, see what kind of systems we have up here and what's going on. So let's set up our surface chart to begin with. Right now we have the base map overlaid on the almost latest radar. There is probably a couple shots later than this. This little system up in North Dakota is probably moved a little bit to the east. And we do have some lake effect snow over New York off of Lake Ontario. And a little bit of a disturbance over Kansas moving into Missouri. So let's put our sea level pressure on this chart. See what systems we're working with. We have a low pressure system over northern Texas. High pressure ridging into Kansas and Missouri. The leading edge of that air mass is probably what's giving that lift. A little bit of moisture advection from the low pressure system wrapping up to the north, and then that high pressure system pushing that up, giving it the lift it needs for that disturbance. High pressure over the northwest. We got onshore flow. We've had that onshore flow. Atmospheric river just pretty much pummeling Washington and Canada. Flooding, rain, mudslides, everything you pretty much don't want out there. We got the low pressure system to the north up in Canada. We looked at this yesterday. We had some thermal advection. I'll throw the isotherms on here now. Thermal advection through the northern United States. That's just a clipper system that's moving east, and then we had that cold air advection with that cold front pushing through. And then now we have another clipper system to the north of that, just north of Montana, that's actually creating some warm air advection and kind of a warm front right there over North Dakota, creating that moisture and that precipitation. So probably some steady rains in that area. Typically when you get ahead of that warm front, you'll get into some stratiform clouds, and that brings more steady rain than it does the rain showers. So let's put the station plots on here. Okay, so if we look at these station plots, we can see where the overcast skies are. The blue is the marginal VFR, and that is ceilings are between 1 to 3,000 feet, and or visibility is between 3 and 5 miles. So you can see this station is reporting snow. We definitely have that lake effect snow. I think there's a winter warning for 3 to 6 inches in that area, and on the plateau, and then on the base of the plateau and the surrounding areas, I think 1 to 3 inches. So if we look at these systems, we have the high pressure system to the northwest. We got onshore flow, some warm air advection, and obviously we will have some upslope causing some lift to create any kind of instability. And then most of this will be frozen precip because it's in the higher elevations. So wrapping around that high, then we get some cold air advection pushing to the south, and then right behind that low. So let me get a pin on here. Okay, so anywhere you see the isotherms cross the isobars is where we'll have advection. Get my pin lit up. So cold air advection in this area. So like I said, with this low pressure system, probably have a cold front kind of wrapping around that high just a little bit, and then with the warm air advection on this side, staying on the warm side of those isotherms. So maybe a little bit of a warm front. We'll pull the fronts up here. We'll do the computer generated for now, but typically you want to analyze this stuff yourself, because the computer generated fronts, their placement usually sometimes is way off. So it's just, you can use it for guidance, but you want to look at these station plots and start analyzing this yourself. So if you look at these wind shifts, like winds out of the west and then winds out of the southwest, that's a wind shift. So we got 47, 46 for temperatures. 50 to 47, so our temperatures aren't changing too much. So that's why I'm putting, like, with the advection we have here, with these isotherms, wind's flowing counterclockwise around that low. Now we have warm air advection, so I'd probably place the it's like a warm front right through there. Now, like I said, out of that low pressure system yesterday, over the northeast, it's moving east, so we had that frontal system kind of pushing to the west, so all of our cold air advection, we want to kind of drop down. Might even be a little bit of an occlusion here, because if you look at this thermal ridging going on, that was going that way. That was going that way. We got a little bit of ridging going on right there. You could almost pull. I'm trying not to erase all of this. I don't think it's going to let me do anything. Let's go. Get rid of that. So maybe pull an occlusion through that ridge a little bit, and then we can bring our cold front back through the ahead of that cold air advection. So place a cold front. That would be purple, would be the occlusion. And then any warm air advection, we might just have a little bit of warm air advection right through here maybe. And then this low pressure system moving to the east. So this is a system I want to keep an eye on. We'll watch that one for development. We'll go up into the upper levels. We'll take a look at that. Let's clear this out. Put the computer generated fronts on here. Okay, so like I said, we pulled this a little bit further north on that cold front. They got the cold front going into the warm front, which that could probably work right there. Definitely they have an occlusion coming out of that low, and then a slight warm front coming off of that. So I would tie these together. Like I said, I would probably just pull that a little bit further to the west. Let's look at our temperatures. Put that cold front a little bit north. You got 47 and 37. 47, 47. So you don't have much of a difference between these two stations. But 47 to 37, a 10-degree difference. I would bring that just to the north. And then bring that warm front. That's okay to bring that down into that cold front. We've got a lot of highs on here, but we got warm air advection. Like we said, onshore flow around that high, and then we got that high pressure system ridging into Kansas, Missouri, and then a little bit of warm air advection. This has that warm front right there, so I would probably bring that out of the low, or warm air advection beginning down here. So bring that warm front south, and then the cold front, 70, 64. So it's pretty good right there where it is. And then that's just going to be a warm front and a cold front, low pressure system. Like I said, I want to keep an eye on that for development. Going to the upper levels. We have this high pressure system sitting in the southeast. Still have some onshore flow in this area. And then so eastern Texas got some ceilings. Broken to overcast skies. They're scattered. And then we get just a few clouds in North Carolina. A little bit of a disturbance right there off the coast of Connecticut, Rhode Island, Jersey. Let me get rid of that. So we have actually got some little bit of rotation right there, indicating a trough. Got the lake effect snow. So if we have troughing in that area, then we could just have a little bit of a disturbance causing that, with the moisture offshore giving us our precip in that area. Alright, so I'm going to clear this out. Let's go to, I'm going to recenter this map. Now we're going to go to the 850. Put the height on here, and let's see what we want to watch that low. Now that high pressure down there, that's this computer system just making mistakes. Just kind of extrapolating data, so it comes up with that. It freaks out a little bit. Let's go see if I can back that off a little bit. I didn't change anything. One more thing I can do, kind of balance the height. Sometimes it'll give us a little bit better flow for this chart. So I took it down a little bit. We still have the high pressure ridging in over the west. We have that troughing throughout the Midwest. Get some isotherms. So we have that troughing over Canada up to the north, just north of Montana. A little bit of thermal advection supporting that frontal system that's going through the Great Lake region, pushing to the west and tying into that warm area. So we got the get the station plots on this. Okay, so we get a drawing tool. Okay, let's go. So we got some moisture here. We need to go look at a satellite. Definitely some moisture there. We did have that system up there. Onshore flow, a little bit of a disturbance there. So everything else looks pretty dry at 5,000 feet. We do have some thermal ridging. We did have that front, or that low pressure system over northern Texas. That's stacking up to, actually right to here. We got winds out of the southeast, winds out of the southwest, and winds out of the west southwest. So we do have some rotation. So we'll place a low pressure system right there. That will stack pretty good with that low pressure system on the surface. And then we can go back and look at, we said a low was here. This isn't really showing us much for contours, but looking at the winds, the way the winds are rotating, we can have almost a little bit of a warm air advection right through this area. A little bit of cold air advection, maybe back here, nothing. There's really nothing going on there. So just a real weak, maybe a closed low right there. Put a low pressure system right there, and then close it off. I would say, okay, close low, weak thermal advection, not if any, and then not really affecting that at all. But like I said, that system is just getting started, so we'll maybe, I don't know if we have time to pull the models. Probably do that tomorrow. See how this system's developing. But right now it looks pretty weak. It's barely making it to the 850. It's at 5,000 feet right now. If we go to the 700 millibar, let's just let this program build a chart for us. It'll have moisture and the contours and everything on it. Might have that crazy high pressure system to the south, but let's see what happens. Looks like we got significant moisture at 700 millibars, definitely over the Great Lakes region, pushing to the east. That's associated with that system, that Clipper system, and then up to the north there is a little bit of weak thermal advection in that area. So let's go to warm air advection right through here. So we still have warm air advection at the 700. It's pretty much about 10,000 feet. We got our onshore flow. Still got plenty of moisture in the northwest, causing all that craziness over there. We got a little bit of moisture in the center of the United States. That's where that high pressure was ridging in. So we still got instability in the upper, starting getting into the upper levels or mid levels, and then definitely got the moisture all the way through the east. So that's going to push off to the east, causing the lake effect snow. We're getting on in New York, Vermont, Maine, up into Maine. That's where we probably will see this system as it pushes east. We'll start getting some snowfall in those in the New England states. So right now, let's look at this low pressure system we have at 500 millibars. I don't really see. I can see a little bit of troughing here. I don't really see a closed low, so we're not going to close that off. We just have an upper level trough, really no thermal advection. You got some isotherms here, maybe pushing into that one right there to give us a little bit of thermal advection. Nothing to the south, a little bit of troughing down here. If you look at the wind shift, kind of some rotation right there, but we don't have our easterly flow to complete that circle, so we can't go against the winds. So we do have a pretty significant trough right there that we could say has upper level support for the low pressure system over Texas. So that is that's a pretty decent developing system that's starting right there. Like I said, we'll pull the models tomorrow. We'll get a good look at that. Alright, and then we'll go to erase that. We'll go to the next level up, 500 millibar. This video is getting a little bit long. Let's see, we're 20 minutes in. Alright, we'll go ahead and let the computer build the 500 for us. We'll look at some 500 millibar vorticity, see what kind of rotation we have, or upper level divergence. That'll give us an indication on how that system's developing also. So we still got at least 60% humidity in the central U.S. A little bit of troughing near the Four Corners over Colorado. We got plenty of moisture in the northwest and plenty of moisture in the northeast, but we're getting more barotropic. Let me get my tool up. Okay, so real quick on this, I see a wind shift here, but I don't see, I'm not going to call that rotation. I'm stacking back on that low pressure system just yet. I'm going to say troughing right here. We definitely got some troughing in that area over Colorado. Really not much thermal advection going on. Really not a. We do have some thermal advection going on right here from the high pressure system, so some warm air advection. So we do have that upper level support for that clipper that's building up in the just north of Montana. That's going to be, I think, the next system that moves to the east. So keep an eye on that. That'll be a warm front pushing through, and then we'll see what kind of weather we get out of that in the Dakotas. With the low pressure system down in Texas, we'll have to, like I said, we got a little bit of troughing here, but we'll keep an eye on that. And then we definitely got moisture in the central U.S. So if that low pressure system develops, it has a little bit of moisture to play with there. And then when I say barotropic, I mean these contours are pretty much parallel with the isotherms, or the isotherms are parallel with the contours, however you want to look at it. So you don't have any thermal advection. So that's if you would have a frontal system, say through this trough, no thermal advection, you're frontal system is going to stall out. That's just going to be a stationary front. So you're looking at a system that is undergoing frontalysis, that just the system's just dying out. So you'll look for that system to weaken when you see this. Now, that's not always true. That you have to see that pretty much through every level, not just in the upper levels. Once you see it in the upper levels, that just means that this system pretty much doesn't have continued upper level support to be a super really intense system. So in the lower levels, if you got a baroclinic system, if the isotherms were going this way and you had that thermal advection, then you have a pretty good support on the surface in the lower levels. But then you get up here and you don't have anything, then you got a decent system, but not what you're really looking for in the upper levels. Is like this low pressure system, we want to see that closed all the way to the upper levels. Thermal advection all the way to the upper levels. Got warm air advection, cold air advection. Now we know we got a well-developed system. Then we look for the jet stream. Jet stream follows the fronts, comes around, troughing. At and ahead of that trough is where your weather is going to be, and then the shooting across that low pressure system. Now, if you had a well-developed system in the upper levels that has a closed low, then the jet stream shoots over that low, over the occlusion, and just creates a vacuum and sucks the mass out of that low, and then helps it even become even stronger. So a lot of features to look for on that. We'll see that more as these systems develop. We'll keep an eye on that stuff, but some of my older videos have some pretty good systems all the way up to 30,000 feet, even higher, with closed lows, thermal advection in those upper levels, and that's a pretty intense. So now, like this system up in the northwest, we have weak thermal advection here with pretty good thermal advection there. Now, thermal packing isn't real tight, so we don't have thermal isotherms real close together, so it's not happening real fast all at once. We're just getting a slow process, but we do have the moisture, we have the thermal advection, so we can expect continued instability in that northwest area. Alright, so I'm going to pull one more. We'll do two more charts, I think. I'm going to do the 500 millibar vorticity chart. Or 500 millibar height. Okay. I want to see our contours on here for 500 millibar height level. That way we can see which way the wind's blowing. And then we can see we have positive vorticity here. And then we have positive vorticity advection in that area. Okay, so right over Kansas, the Ohio Valley, West Virginia, just over the Appalachians, and then well to the north, we got positive vorticity advection where that low pressure system is developing north of Montana. So we have upper level support, upper level divergence. So as that low pressure system moves to the east, we're going to have upper level divergence. We're going to have that upper level support to the north to help that system develop as it moves east on that clipper system. So this system in Texas, we stacked back a little bit into a trough. This is even 500. We have that trough right there. So at and ahead of the trough is where we got to look for it, any instability. So we see that with this positive vorticity advection. So now we have upper level divergence. Now it can take the mass out of that low that's over there, over Texas, and just pull that mass out. Now, depending on where our jet stream is, we'll have to see exactly where that jet is, and then if that shoots over this low enough, gets close enough to that low pressure center on the surface, we can pull the mass out of there even more, and that can become a pretty well developed system. So, like I said, we'll see how it goes tomorrow with the models, but we'll wait till that model run comes out. But I think this thing's going to develop a little bit. Now, where it goes from there, it's hard to say because we did have the high pressure in the southeast. We got the high pressure in the northwest. We had the high pressure ridging into, actually, it was right through there into Missouri, Kansas, kind of in that area. So is this high pressure going to block that low from moving? Because high pressure always rules. Low cannot push a high all the way. High pressure will push a low. It will steer around that high. So we'll have to see what happens there with the high pressure system. Is it going to die out, move south, move back out to sea, then allow that low to come over? This high pressure system, all it's going to do, if anything, is just weaken, or even if it starts ridging more, then we got even more support for that low pressure system to the north to continue to develop and push east. So we'll have to see what happens with this and that high pressure system. So positive vorticity advection all through these areas. That's a good sign for development. All right, one more. We'll go up to the 300. Now we're going to just pull the jet stream. Put the contours, isotherms, and the station plots. Alright, if we want, we can label this 300 millibar. So now okay, so now we got the jet stream pretty much pushing right down through this area and then back up. So let's clear that out. I'm going to go try to keep it right. Go through the jet max and then over. See the tightest areas. And the green's probably a little hard to see on the green. So right there's the tightest packing. There's our jet stream pushing through the center of that jet max. Nice ridge over the northwest. That's with the high pressure system. We definitely got ridging all the way up to 300 millibars. And then we have a little bit of ridging here. A little bit of troughing here. We can see this rotation right there. So we got some troughing in the upper levels. That's just an indicator for some instability. That low pressure that was over Texas, we don't really see anything. We got a pretty weak winds over Texas. Anywhere that low pressure would stack to, up into Colorado or toward the colder air, then that's the support we're looking for there, but we don't really have anything on that one. So we got jet support for that low pressure system north of Montana, so that one definitely could develop. It looks like it's going to move to the east. We got this jet max pushing into this trough, so that may deepen that trough just a little bit as far as that low pressure system way out to the northeast, and then maybe a frontal boundary that's way off the coast. But we had that low pressure system up here, and then we have, clear this out a little bit, then we had that cold front that kind of came back into the warm front. We still got some warm air advection a little bit going on right here. A little bit of warm air advection there. Pretty weak though. So that kind of went with that warm front, and then the cold front pushing to the west out of that low up north. So as this one continues to push east, we're going to see pretty significant weather in the New England states. I would look for the snowfall in Vermont, New Hampshire, Maine, and then any lake effect you're going to get from Lake Erie, Lake Ontario, over New York. Watch for that. Would be the most significant snowfall from that system. This next Clipper system, as it moves through, then we'll have to keep an eye on it. How deep does that low go? And then what kind of significant weather it causes for the Northeast also. Even over the Great Lakes region, over Michigan, that's where you're going to get most of your snowfall. And then we'll do one more chart after this. We're going to do a thickness chart to see where our 540 line is. That cold air moves out of Canada. We get, the 540 line can drop south. We need to see how far south it is. But we do have jet support for these systems. The low up here, that one's pretty much going to just push off, keep pushing to the east, and then just die out. That frontal system's moving westerly. Then we got that warm front over that system north of Montana. So that'd be the next system to come through. Just a train of clippers just pushing through. So my main system I want to look at is the one over the Panhandle of Texas. What happens with this high, and then we're going to find out where this high allows this low to go. So we'll keep an eye on that in the next couple of days. We'll pull the models tomorrow to do that, but let me go back and do the thickness chart real quick. Go back to the surface. Pull the 1,000 to 500 millibar thickness lines. The 500 millibar contour heights minus the 1,000 millibar contour heights. Then whatever that value is what you'll get for the thickness lines on the thickness chart. So a couple videos ago, look for thickness chart analysis. We cover a lot what you can do with this chart and how you identify these features. So I'm going to go surface sea level pressure, and then we're going to put some station plots. Okay, so alright, we got the high pressure in the northwest. We got that low pressure over Texas. Now our thickness lines are going to be where they're the tightest. We know we had that jet max right through there. That's where the jet stream is. So that jet stream is pretty accurate for what we had there. A little bit of ridging over this area, a little bit of troughing in this area. So we got we're looking at through here. We got our thickness lines and a surface pressure. So we have what we're looking for is where these thickness lines cross the isobars. So you do have a little bit of advection right there. That's where that warm front is. So that'd be the placement of that warm front. This should be red. Missed it. Alright, so there's the warm front. Do we have any cold air advection? Pretty weak, but it'd be right through here. So we do got ridging right there, right behind that front. So we tied that front into that warm front, the cold front into the warm front, and then low pressure to the north. But we look at this jet stream, placement of the fronts. And then we do have a little bit of circulation going on right there. That's where that low pressure system is. So, but here's what I want to look at, was that 540 line. See what my values are. See if I can pull this out here. I got our 540 line must be well to the north. Here it is. This is where your rain snow line is. So it does drop pretty far south with that jet stream. So anything north of that's going to be snow. So we do have snow there already, the lake effect. So our 540 line is there, but now as this low pressure system over north of Montana develops and moves east, we have a trough here, ridging there. So the ridge is going to push in, maybe dry that out a little bit, not much. That's a weak ridge. And then this trough, as that low pressure system develops, start pushing east. Keep that moisture, run over the Gulf, the Great Lakes, and then that's going to pick up any moisture it needs there, and then continue to push east, and then probably be a repeat of this system. Just lake effect snow, more snowfall in the New England states, and just adding to their accumulation. So, like I said, there's a plateau over New York, lake effect looking 3 to 6 inches. Anything at the bases 1 to 3 inches, and then keep an eye on what's going on in Vermont. I'll be watching that. Now, like I said, this adding to the accumulation, but with that 540 line that far to the south, then any precipitation that happens would pretty much would be snow. Find that 540 line again. I'm going to get a clear picture of that. So, alright, here we go. Pushing through Columbus. That's going to continue to push north. So by the time this long wave trough moves out, then that 540 line is going to move to the north. Any precipitation we get, which we'll probably get a little bit of this tomorrow, as far as that warm front moving through, a little bit of disturbance here, pushing through with the jet stream, just kind of pushing easterly. We are expecting some rain in southwest Ohio tomorrow, and that's pretty much, it's all going to be rain, just because this 540 line's over Columbus, but it's going to continue to push east with that long wave trough, and then any snow might still remain with some lake effect in the Lake Erie area. So, alright, I'm going to call this quits here. I want to say thanks for watching. I hope you learned something. If you have any questions, put them in the comments. Like I said, tomorrow we're going to cover the models, chase those out, see how these systems develop. We'll mainly look at the system over Texas, and then that system over north of Montana, and then another Alberta clipper that's pushing through, and then see what happens with this high pressure system. Is this thing going to die out, push off, break off, become its own little high, or is it going to go back over the Atlantic, allow this low pressure system to develop and push to the east? So let's keep an eye on all that, and in the meantime, keep your head in the clouds.